So what you see here is I've given you three reactions, and we're going to use these three reactions to find the delta H reaction of this. Conceptually, those three reactions are all combustions, which is feasible to do in a lab and to measure the amount of energy that goes out. And I can then use those to find the energy change of a reaction that I can't do in a lab. Here's my approach to this problem. I go through each reaction one by one, and I look at what does it have in common with the overall reaction. So first of all, this first reaction, reaction one, what does it have in common with my goal reaction? C2H4. Then I ask myself, do I have the correct number of them? 1 and 1, yes. Are they on the correct side of the reaction? Yes. So I don't have to do anything to that first reaction. So I'm just going to rewrite it. And since I didn't do anything to the reaction, I don't do anything to the delta H reaction. Okay, reaction 2. What does it have in common with the goal reaction? H2O. Do I have the correct number of them? Yes, 1. Is it on the correct side? No. I need to reverse this reaction. So if I reverse that reaction, what was my products is now my reactants. And what was my reactants are now my products. And since I reverse the reaction, I take that delta H and I change the sign of it. Okay, reaction 3. What does it have in common with the goal reaction? H2. Correct number of them? Yes. Correct side of the reaction? Yes. Don't have to do anything. So I don't do anything to the heat. Okay, now, if I manipulated these reactions correctly, when I combine them, they're going to add up to my overall reaction. So what I do is I cancel things that appear the same way on each side of the reaction. Total. So if I look at, I have 2 CO2 over here and 2 CO2 there, so I can knock those out. I have 2 free waters on the right, 3 waters on the left. We can cancel that. The H2s, or I'm sorry, the O2s, we have to do some fraction math. 3 plus a half is 3.5. 7 halves is also 3.5. So those are all gone. Now I'm left with these and that. So indeed, this is my goal reaction. So if I want to get the delta H reaction, I'm going to sum those three values. Negative 1411 plus 1560 minus 285.8 gives me negative 136.8, and that's my answer to the problem. We're going to take a look at one more example together, because this one does something that a lot of the reactions do. I'm going to start this reaction the same way, where I look at, what does it have in common with the overall reaction? Do I have the correct number? Are they on the correct side? But the problem is oxygen. Oxygen is in the overall reaction, but it's also in multiple of these. So I'm going to ignore it to the end and hope it works out. Spoiler, it works out. Okay, so looking at reaction 1, what does it have in common with the goal reaction? Looks like NO. Do I have the correct number of them? No. Is it on the correct side? Yes. So I'm going to double this reaction, giving me 2N2 plus 2O2 gives me 4NO. And I'm going to double the heat, negative 180.5 times 2 gives me negative 361. On to the next reaction. What does it have in common with the overall reaction? NH3. Correct number of them? No. Correct side? No. So I need to reverse and times 2. So 4NH3 will become 2N2 plus 6H2. So I'm going to multiply this by 2 and then change sign. So 91.8 times 2 gives me positive 183.6. Third reaction. What does it have in common with my goal? It has water. Correct number of them? No. Correct side? Yes. I need to triple this reaction, which will give me 6H2 plus 3O2, forms 6H2O. Triple the reaction, I'm going to triple the heat, 43.6 times 3, negative 1450.8. Now, theoretically, I did these right, and I can just add up my delta H's at this point, but I'm going to be a good student and check to make sure that things canceled. So let's see what appears on both sides of the reaction. I have 2N2 there, 2N2 there. That seems to be, no, 6H2, 6H2. Now that seems to be all that'll cancel. So now rewriting this reaction, 4NH3 is still present on the left. 2 O2s plus 3 O2s is 5 O2s, 4 NO, and 6 H2O. And that works out just like my goal reaction should. So now I'm going to add up my delta H's. Negative 361 plus 183.6 minus 1450.8 yields negative 1628.2 kilojoules per mole. All right, got one for you to try.